Hey guys, so I hope you guys are ready to do some matrices because we are going to move forward today. In my previous videos, we learned how to describe a matrix based on its order. We also learned some properties of addition and subtraction of matrices. And we also learned how to recognize if matrices can be multiplied and how to multiply matrices. Um, I believe in the last video, we also touched on an identity matrix as well, and how the impact of multiplying by an identity matrix is nil. So those are just some points that I would like to recap. So you could call this video 4 if you like. If we're going in an order, I may assign each video a particular name so you guys, if you're revising from start to finish, you'll know which order to follow. So this video is called the transpose of a matrix, and though this is very tiny, it's just a small little nip in the bit of matrices. It's not such a highlighted topic. I would like to expose you guys to everything because you never know what's gonna come. And with matrices, every bit of information is essential. So exactly what is the transpose of a matrix? I mean, when you think about the word transpose, what comes to mind, right? Transpose sounds like something's changing or transforming, right? And if that's what you were thinking, you are correct. The transpose of a matrix is simply found by interchanging its rows and columns. So in a nutshell, let's just say, for example, we were given this matrix and we called it A. Its values are -1, 9, 4, 7. And they're asking us to find the transpose of this matrix. Now, first of all, notation. The transpose of a matrix is denoted by a subscript of T. So you would see that very popular if you see a little superscript, notation of T where the power of something is supposed to be. They're just asking you to find the transpose of a matrix, and this is how we would interchange rows by columns. So we're going to have our bracket. We're going to open it up here, and very simple. Let's look at our first row, and you can identify that your first row is -1, 9, and it's written horizontally. So what we're going to do is we're going to write that vertically instead. So instead of -1, 9 being written horizontally, we're going to simply write it vertically. And that was row 1. We're also going to transpose row 2. We had 4, 7 written horizontally. Now we're going to write it vertically so that it becomes 4 with 7. And I have a lot of students asking, Miss, do we transpose the rows, or do we transpose the columns? Any direction you essentially take it from, you actually get the same answer. If I were to consider my first column, which is -1, 4, and I wanted to write that horizontally, it'll become -1, 4 horizontally, which is in essence the same thing we have here. Similarly, if I were to consider my second column, 9, 7, and I wrote it horizontally instead, it becomes 9, 7 horizontally. So the approach you take when you're transposing a matrix, it really doesn't matter if you choose to transpose rows into columns or columns into rows. You'll actually end up getting the same answer. So transpose of a matrix is very nice. It's very straightforward. I think I'll show you guys a second example here. All right, just so we're clear on what we're essentially doing here. So for example, let's just say they gave us a matrix B, and let's take a big one here. That was 3, 2, 0, -1, 6, 7, 4, 3, 5. What would the B transpose be equal to? Well, here I'm going to choose to write my rows as columns. So I'll take the first row and I'm going to write it vertical. So you'll get 3, -1, 4. Now I'm going to look at my second row and I'll write it vertically. Then I'm going to take my third row and I'll write it vertically. Let's B transpose. That's it. That's easy. So transposing a matrix is just simply found by interchanging the rows and columns. And it's very, very nice, very, very easy, very straightforward. You can transpose any types of matrices. They would result in different rows and different columns, obviously, but the method is essentially the same. There are some properties you should know. For example, some common properties that you should know in matrices are, 1, if you were to transpose a matrix, right, and it's already transposed, right? Let's just say after transposing a matrix, you were to transpose it again. Guess what happens? You get back the original matrix. And it makes sense because upon transposing, your rows become columns or vice versa. Then if you undo it, you go back to your original. So that first property totally makes sense. You guys can try it out. The second property of transposition is that if you have any constant k, it can be a number, it can be a fraction, it's just a constant value, and you were multiplying matrix A by a number, let's just say, and after multiplication, they asked you to transpose, you actually would realize that it's the same as if you had not multiplied that matrix by the constant as yet, and you performed your transposition first, and then you choose to multiply by a constant. So let me explain what I mean here. Let's just say we had 3 brackets 2, 1, 5, 6. All right. And then they asked you to find, this is the matrix A here, this is your constant, and they're asking you to find K multiplied by A and then transpose. Well, there's one of two ways you can do this. You can choose to multiply 3 by each of your numbers inside of that matrix, 3 by 2, 3 by 1, 3 by 5, 3 by 6, and then you can transpose. Let's do it on screen. So you will get 3 by 2 is 6, that's 3, that's 15, and that's 18. All right, so what we have done here is we have found a K multiplied by A. The question is asking us to find the transpose. So if we were to transpose this, we'd get, I'll write my 6 and 3 vertically down, and then my 15 and my 8 vertically down. Now, this is our final answer. This is K A transpose. Now, there's a second way you could have done this. And the second way you could have done this is simply by, like they said, all right, like they said, you could have found K A transpose, meaning that you set that constant 3 alone, and the first thing you do is transpose, and then you multiply by 3. So if our matrix were 2, 1, 5, 6, if I transpose that, I'll get 2, 1 here, and then I'll get 5 with 6. And then if I were to multiply after, I'll still end up getting 6, 15, 3, and 18. So you can see that these two answers definitely coincide with each other. So the property where if you are multiplying by a constant and they're asking you to transpose that matrix after, it's the same as you can transpose and then multiply by the constant, you'll get the same answer. All right, so that's a good point to note. Now, here's a big difference here. What if you had two separate matrices and you had to multiply them? We did matrix multiplication in the previous video. So you guys know that it's a long process and it produces, you know, different orders of answers. You could end up with a 3x2 matrix. You could end up with a 2x2 matrix. It all depends on the order of the matrices you're multiplying. What if they ask us to transpose the answer of the product of two matrices? Is that the same as transposing the first matrix and multiplying it by the transpose of the second? No, it actually is not. If you were to test this property, it's actually the same as transposing the first matrix and then multiplying it by the transpose of the second matrix. So this is a nice little property. You guys can, it can pop up in a proof. It can pop up in a proof. They can give you two matrices AB, and they can ask you to prove that AB transpose is the same as B transpose A transpose, right? So you would just have to work it out, an answer for the left-hand side and then a solution for the right-hand side to prove that this is true. And then finally, just a couple more things I wanted to mention about transposition of matrices is that we have, for example, you guys recall what a square matrix is, right? You guys remember a square matrix essentially is that you have a 2x2 or 3x3 matrix, or 4x4 or 5x5, right? They have the same number of rows and columns, right? So a square matrix can also be symmetric, right? So point to note, a square matrix is said to be symmetric if and only if, take note that this is the notation and it means if and only if. For those of you who've never come across it before, it means if and only if. Okay, this is a shortened version for it. A square matrix is symmetric if and only if after transposing it, you get the same thing. So for example, if you were to consider the matrix 1, 2, 2, 1, right? If we call this matrix A, and we were to transpose this, if you transpose this, the first row 1, 2 written vertically becomes 1, 2 like that. And the second row 2, 1 written vertically becomes 2, 1 like that. Now, if you compare, it's the same matrix. We have A being the exact same thing as a transpose. Whenever you transpose a matrix and it looks like the exact same thing before and after, it's kind of like twinning, you know, it's like the same two people, they're mirror images of each other, kind of. So it's called symmetric. If that situation happens, these matrices are said to be symmetric, okay? And also, another property of square matrices is that if, let's just say you are transposing a matrix, right? So if the transpose of this matrix turned out to be negative A, so they are not exactly the same. Let's just say you ended up getting a negative sign instead in front of each value, right? So almost the same except for the sign. Then the square matrix has a name, and it's actually called, there's a particular word for it, and it's called skew. My spelling. It's called skew symmetric. All right, guys. So that's my spelling. You know what it is. So a square matrix is called skew symmetric if after transposing you happen to get the original matrix except every element, the sign is different. Okay, so these are some nice properties to remember. They tend to be very useful. You never know when they pop a question and they're like, transpose this matrix. Is it skew symmetric? And you've literally never heard the word. But now you have. Yay! So guys, I don't want to make this video very, very long. I was thinking of testing the third property with that transposition, but I think I'll wait to see if you guys comment on the video that you would like a tutorial on some transposition of matrices to test those three properties. Which properties am I referring to? If you would like to see, well, I actually showed you guys the first one, but if you would like a tutorial where we run through some examples testing these three properties, you guys would have to comment below the video and like, and then I would get into a tutorial based on how popular of a demand it is. So guys, not too shabby, not too shabby. I'd say transposition of matrices is a good break. You know, it relaxes the mind after getting into that intense multiplication. Yeah. So guys, it's going to get very, very nice from here. I'd say multiplication is perhaps the longest part in matrices. So next session, we're going to get into some determinants. And then hopefully sometime in the future, we can begin to solve equations using matrices and so on, guys. So looking forward to having you back with me next video. Take care, all the best, and good to be with you. Bye.